Welcome to ClickMyProject.com. Now we are going to discuss about the project Spectrum Efficiency Improvement Quasi-Constant Envelope OFDM. We are going to discuss about the abstract of this project. In this process, we have used Constant Envelope OFDM, which is a promising technique in coherent optical communication benefiting the peak to average power ratio. The spectrum efficiency of CE-OFDM is half of a conventional coherent optical OFDM, which restricts its application. In this, we have proposed a novel quasi-constant envelope OFDM within phase and quadrature modulator. A phase demodulation scheme is used, which is based on Taylor series expansion, and it is performed to reduce complexity and avoid phase ambiguity. The result of this project doubles the spectrum efficiency by using quasi-CE-OFDM without losing the advantage of nonlinearity tolerance. We are going to discuss about the flow diagram of this project. In this, the first block is parameter initialization. This is used to initialize all the parameters that is necessary for the project, and we can use it in the coding by initializing it. Then the second block is the OFDM system. This project has been done through the OFDM system. In OFDM system, the first process is data generation. After the data is generated, we have undergone modulation. That is, we can use QAM modulation in this process. We have did 64 QAM modulation in this project. Then, to safeguard our data, we are adding cyclic prefix. That is, it is added to safeguard our data and it is transmitted in the same form to the receiver side. Then we can do signal to parallel conversion, and IFFT is taken for the transmitted data. Then the block is optical signal generation. In this, we need to generate a signal, which is a laser pulse is used in this project. The laser pulse acts as a pilot insertion in this project. The laser pulse is added to the OFDM transmitter and it is added in the receiver side also. In the receiver side, the OFDM is added through 90-degree hybrid. That is, the laser pulse is passed in the 90-degree hybrid and then it is given to the IQ modulator. The IQ modulator is used to separate the real and imaginary signals. That is, in phase signals and quadrature signals we get in the receiver side. Then the quasi-CE-OFDM, which is a quasi-constant envelope OFDM. It is used in this project. In this, the IQ modulator, that is in phase and quadrature modulator signals are passed through this module and it is differentiated compared through PMCE-OFDM, which is phase modulator constant envelope OFDM, RF-CE-OFDM, which is RF signal constant envelope OFDM, and CE-OFDM, coherent CE-OFDM. The quasi-CE-OFDM is compared with all these three OFDM, which gives an high spectrum efficiency in quasi-CE-OFDM. The performance evaluation block. In performance evaluation block, we perform the simulation setup of quasi-CE-OFDM, in which we compare all the OFDM system with quasi-CE-OFDM, and the result we get is that the quasi-CE-OFDM has high spectrum efficiency and there is no linearity tolerance. Then the performance of BER at different OSNR. That OSNR is nothing but optical signal noise ratio. The optical signal noise ratio is set and we are finding bit error rate for this signal. Then the performance of Q value with different launch power. The launch power is given by using the optical signal and we are finding the Q value for all the different OFDM systems. Thus, it proves that the quasi-CE-OFDM has high spectrum efficiency. Now we are going to discuss about the running process of this project. This is the command window for Matlab. The version is R2017B. In this, the coding is in the main file. Now I'm going to run the coding. The coding is in running process. We'll get the output in a graph. That is, we have got two figures. The first figure is with Q value with launch power. In this, the Q value is plotted with launch power. the four OFDM systems are plotted, which is quasi-CE-OFDM, PM-CE-OFDM, RF-CE-OFDM, con-CE-OFDM. In this, the first three are gradually constant and the con-CE-OFDM has been decreased. In this, the quasi-CE-OFDM is found by using the Q-value formula, and the PM-CE-OFDM, RF-CE-OFDM and con-CE-OFDM are plotted statically. Thus, the quasi-CE-OFDM is main for this project, so we have calculated it using the Q value. Then the second graph is BER with different modulation index. The modulation index has been differed from 0.4 to 2, and the BER is calculated. BER is a bit error ratio. Then the OSNR is, there are three OSNR values. OSNR is nothing but optical signal to noise ratio. The first one is OSNR 13 dB, OSNR 15 dB and OSNR 17 dB. These are static and BER is calculated by using a formula. So in the formula we are substituting the OSNR value as a static one, and we got the graph which is gradually decreasing, from the up. That is, the OSNR is calculated for quasi-CE only. As the main objective of this project is only quasi-CE-OFDM, so we have calculated quasi-CE-OFDM for all the processes. Then this is the running process of this project.